In this question, we're going to do a factor theorem question from the beginning. Suppose you are asked to asked to factor negative 30x to the 6 minus 215x to the 5 minus 295x to the 4 plus 705x cubed plus 1,585x squared plus 770x. How would you do it? Well, first thing you would do is always common factor if you can. So we'd factor out negative 5x, and inside the bracket we'd be left with 6x to the 5 plus 43x to the 4 plus 59x cubed minus 141x squared minus 317x minus 154. Okay, now inside that bracket, we've got ourselves a fifth degree polynomial. So what we're going to do is we're going to try the factor theorem on it. And I'm going to just imagine that what's inside of here is f of x. And I'm going to plug in an x value of 1. Well, when I do that, when I plug an x value of 1 in and I evaluate 6 times 1 to the 5 plus 43 times 1 to the 4 plus 59 times 1 cubed minus 141 times 1 squared minus 317 times 1 minus 154, I do not get 0. But when I plug in a negative 1, I do. Well, what that tells me is that x plus 1 is a factor. Okay, good stuff. So now what we do is we do synthetic division. I'm going to synthetic divide x plus 1 out of that fifth degree polynomial. Okay, so we bring down the 6. Okay, negative 1 times 22 is negative 122. Okay, oops, sorry. This is a 154, and then I add that and I get a 0. Okay, so x plus 1 is a factor, and now I'm left with here 6x to the 4 plus 37x cubed plus 22x squared minus 163x minus 154 as another factor. Well, I'm now going to look at this, and I will think of this as f, or if I want to use a different letter, g. Well, since f at 1 did not equal 0 up here, there's no point in me plugging in an x value of 1 to this one down here, to the fourth degree polynomial, because it won't work. If it didn't work once, it won't work again. However, here where I have f at negative 1 equals 0, negative 1 worked, it might work again. So let's determine what g at negative 1 is, and I'm going to let g simply be that fourth degree expression. When I do that, I see g at negative 1 is 0. So that means x plus 1 is a factor again. It's a factor twice. Awesome. Okay, so now that I know it's a factor twice, I can factor that out using synthetic division. Drop down the 6. Awesome. Now what I've got is a third degree polynomial, 6x cubed plus 31x squared minus 9x minus 154. Well, since x plus 1 is a factor once and then it's a factor again, gee whiz, it might be a factor again. But when I plug in negative 1 this time, it doesn't work. It does not equal 0. But when I plug in h at 2, it does equal 0. When I plug in a 2 for x in this cubic polynomial that I just underlined, So now what I can do is I can factor out, do synthetic division on the binomial x minus 2. Okay. Now when I do that, 2 times 6 is 12. 31 plus 12 is 43. 2 times 43 is 86. Negative 9 plus 86 is 77. 2 times 77 is 154. Add up that last column and I get a 0. So what I know is that x plus 1 was a factor 2 different times, and x minus 2 was a factor 1 time. And then I also had over here this factor of negative 5x. So what I'm left with down below with that 643 and 77 is 6x squared plus 43x plus 77. But I know what that equals. 6x squared plus 43x plus 77. We can use our decomposition method or our charting method or our crisscross method, stick method, ratio method, whatever it is we use. It actually equals 2x plus 7 times 3x plus 11. So we see here we've got a whole bunch of factors laid out. So now we can state our final answer. We see that negative 30x to the 6 minus 215x to the 5 minus 295x to the 4 plus 705x cubed plus 1,585x squared plus 770x, deep breath, is equal to negative 5x times x plus 1 twice, so I can put a squared there, times x minus 2 times 2x plus 7 times 3x plus 11. And we've got ourselves an amazing final answer for the answer box on the test. Okay, so that's how you approach a factor theorem question, and I hope that was helpful.